So let's use just a simple function like something like y equals x squared plus 4x plus 4. And see if we can figure out where this has horizontal tangent lines. Is that what you're asking about? Just something simple like that, just in general?
Yeah.
Okay, yeah, so a horizontal line, we should know that a horizontal line always has a slope of 0, right? And so if we're looking for the tangent line to be horizontal, then that means that the slope of the tangent line has to be 0. And so we'll take our derivative, we'll find y prime because that represents the slope of the tangent line, so 2x plus 4. And we will then just see when does that slope equal 0. And so that just gives us that the horizontal tangent line for this particular function occurs at x equals -2. Does that make sense? Does that help?
Yeah, it does. Thank you.
No problem. Any other questions on anything we've done with derivatives before we finish up the trig stuff? All right, let's take a look then at our first problem here. We're going to find the second derivative of secant x. You should already know what the first derivative of secant x is. What's the first derivative of secant x? You should have memorized all those rules over the weekend.
Secant of x times tangent of x.
Secant x, tangent x. Perfect. And so then to find our second derivative, what rule are we going to need to use?
Product
Rule, right? Because we got a product of two functions, secant x times tangent x. So we'll use secant x times the derivative of tangent. And what's the derivative of tangent?
secant squared x.
Secant squared x, good, plus then tangent x times the derivative of secant x, which we already talked about. So I'm going to ask you that one, secant x, tangent x. And if we want to simplify this down, we could take a secant out of each of these. So secant x times secant squared x plus tangent squared x. Everybody good with that? Any issues there? All right. Let's see if we can write the equation of the normal line to y equals tangent x at the point pi over 4, comma 1. So you're going to hear me ask this question a million times this year probably, but in order to write the equation of a line, what do we need to have? We need two things. First thing we need is a point, right? And the second thing we need is a slope. And if we're looking for the normal line, we know that the slope of the normal line should be the opposite reciprocal of the slope of the tangent line. So we need to find the slope of the tangent line for y equals tangent x. So we'll need to find its derivative. And we already said the derivative of tangent x is secant squared x. So we need to find out what does that slope equal at pi over 4, right? Because that's what our x coordinate is. So what is secant squared of pi over 4? First off, we'll need to know what is secant of pi over 4, and then we'll just square that value, right? So what's the secant of pi over 4? Okay, if you don't know the secant of pi over 4, you should know what the cosine of pi over 4 is, right? Should be the same as 1 over the cosine of pi over 4. What's cosine of pi over 4?
Square root of 2 over 2.
Square root of 2 over 2. So this is 1 over root 2 over 2 squared, or we could take the reciprocal of that, so that'd be 2 over root 2 squared, which what does that equal?
2.
That equals 2. And just for 1 second, before we squared that, what does 2 over root 2 equal? Two over root 2 should be just square root of 2, right? So the secant of pi over 4 is root 2. So that's a value you should know, or at least should be able to find out really quickly. But we end up with the slope of the tangent line is equal to 2. If that's the slope of the tangent line, what is the slope of our normal line equal?
-1/2.
-1/2. So when we plug this into point slope form, we should get y minus 1 equals -1/2 times x minus pi over 4. Everybody good with that? Everyone good there? No questions? All right, let's take a look at this one. We've got 2 options here. What are our 2 options?
Product rule?
Okay, one option is the product rule, right? Cotangent x plus cosecant x times tangent x minus sine x. So that would be a product rule. What's another option? What could we do before we use the product rule to maybe make this simpler?
Sum and addition rule.
Say that again?
Sum and addition rule.
I'm not sure what you mean by that.
Like taking the derivatives inside of the.
Oh, okay. I see. No, we can't do that because this is a product. Like the outer piece of this is a product of 2 different functions. So we can't do the derivatives of the insides first and then multiply. We have to do the product rule, or we could simplify first, right? How could we simplify this?
Could you distribute it?
Yeah, we could distribute it out. So what's cotangent x times tangent x?
1.
Okay. And what's cotangent times negative sine? Well, that's negative sine x times cotangent x, which is cosine x over sine x. And then what about cosecant times tangent? That'd be plus 1 over sine times sine over cosine. Everybody agree with that? And then plus cosecant times negative sine. What's cosecant times negative sine? Should be a -1.
1.
So the 1 and the 1 cancel out, right? And then the sine over the sine cancel out. So this just becomes negative cosine x. And the sine over sine cancel out here. So we got negative cosine x plus 1 over cosine or plus secant. Everybody good there? That's just the simpler form of f of x. And so what is f prime of x equal? What's the derivative of negative cosine?
Sine of x.
Should be sine of x. And the derivative of secant x?
Secant x tan x.
Secant x tangent x. Any issues with that? If we tried to use the product rule first, and I'm just gonna like say a bunch of stuff real quick here, we would have got cotangent x plus cosecant x times secant squared x minus cosine x plus tangent x minus sine x times negative cosecant squared x minus cosecant x cotangent x, which would have been a giant mess of stuff to simplify. So most of the time when you try to take the derivative of a bunch of stuff with trig functions, you want to try and simplify that expression as best you can first. So always simplify first if you can. Any questions or issues with that? All right, we got a couple more, and then we will move on to our quiz. So, how are we going to find the derivative of sine x over 1 plus cosine x? What rule will we use?
Quotient rule.
Quotient rule. And is there any simplification we can do first with that that anybody sees? I don't see any. So let's just try and take the derivative. Let's use the quotient rule. Quotient rule says denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. What's the derivative of 1 plus cosine x?
Negative sign.
Good. All over 1 plus cosine x squared. Everybody good with that? Okay. And I can simplify this numerator. I can distribute the cosine. So I'll get cosine x plus cosine squared x plus sine squared x all over 1 plus cosine x to the second power. And what does the numerator then simplify to?
Cosine x plus 1.
Cosine x plus 1 or 1 plus cosine x, which gives us 1 plus cosine over 1 plus cosine squared, which we can then simplify to just 1 over 1 plus cosine x. Everybody good? Any issues with that one? All right, last one before we take the quiz. So we want to find the slopes of the tangent lines to y equals sine x at these 5 values, and then I want you to tell me which ones are horizontal tangent lines. So that should be pretty easy. Should be an easy derivative. So what's the derivative of y equals sine x? Y prime is
Cosine x.
cosine x. And so at x equals 0, what's the slope of the tangent line?
1.
And at pi over 3, the slope of the tangent line is
Pi over 2.
at pi over 3, what's the cosine of pi over 3?
Root 3 over 2. Wait, it's 1 over 2.
Yeah, it's 1 over 2. All right. What's the cosine of pi over 2? Slope of the tangent line at pi over 2 should be
0.
0. All right, so that's a place where the tangent line's horizontal, right? So we'll go down here at pi over 2. Right? What about at 2 pi over 3? What's the cosine of 2 pi over 3?
Negative 1/2.
Negative 1/2, good. And the cosine of pi should be negative 1. So of the 5 values we had there, only one of those points is the tangent line horizontal. Everybody feeling okay with the basics of taking derivatives of trig functions and being able to evaluate them at certain values? Okay. Make sure that for any value on the unit circle, 0, pi over 6, pi over 4, pi over 3, pi over 2, and then in the second quadrant, all of those same ones, third quadrant and fourth quadrant, you know the sine, the cosine, and the tangent for all of the angles on the unit circle in all 4 quadrants. If you don't have the secant and cosecant and cotangent ones memorized, it's not the end of the world. Just know that they're reciprocals of the sine, cosine, and tangent ones. So if you know sine, cosine, and tangent, you should be able to find the other 3 really easily by taking the reciprocals. But you really do need to have those memorized. Okay, so if you don't do that this week. Any other questions on any of this before we take the quiz?